Hi folks, this is the last video for the afternoon of Thursday, February the 4th. This topic is called solubility, and we are still on intermolecular forces. The whole idea of solubility is huge in chemistry and the real world. It's also called light dissolves light. Things that look alike will dissolve together. Whether you're in the foods industry, you're in the fuels industry, if things won't dissolve together, they can't react. So we need things that will dissolve together to get them to react. You take for an example, if you're eating a popsicle on a hot summer day and it drips all over your hands, you should only need water to wash that away, because the sugar has OHs, the water has OHs, so they hydrogen bond together, they dissolve, it washes away. So here's the whole idea. We've talked about dispersion forces, we've talked about dipoles, and we've talked about hydrogen bonding. If you've got two molecules and you want to know whether they'll mix or not, try and classify them first. Are they dispersion, weak dipole, strong dipole, hydrogen bonding? If they're close, they can dissolve. So if we've got two molecules that can hydrogen bond, then they will dissolve together. If we've got two things that have dispersion forces, they can dissolve together. So if we analyze the first pair, we've got a 3-carbon molecule and a 5-carbon molecule. Are they the same? No. But do they have the same properties? Yes, they both have dispersion forces. They should dissolve well. What you get marked on when you're analyzed on this is your ability to explain. You might not come up with the exact same explanation as somebody else, but as long as you can show that you can analyze the molecules, that's what counts. If you take a look at, let's take a look at this grouping here. When if we ask the question, which will dissolve better in 2-propanol? Will it be this molecule here, this propanone, or this 2-chloropropane? Well, let's see how close they are on the list. The closer they are together, the better the chance they have of dissolving. You can see the 2-propanone is very close on this list, so it could dissolve. The weak dipole is further away, so it won't dissolve as well, probably weak dissolving ability. The other clue you can look at is you've got an OH on this molecule and an O on this molecule. So even though this one's a dipole, it can still hydrogen bond with this molecule. So if two things can hydrogen bond together, they're going to dissolve well. So, next question. Which one is going to dissolve with this molecule right here? Will this dissolve better or this? Well, see where they are on the continuum. The 2-chloropropane is closer to this molecule than the 2-propanone is. It's further away on the list. Therefore, this could somewhat dissolve in here. It's not exactly a dispersion and a dispersion, but they are fairly close on the list, so they will dissolve pretty well. Okay, folks, once again, watch this video a couple of times, take good notes, and please contact me if there are any issues.